Let's understand this k-nearest neighbor, the most popular machine learning algorithm. So what is k-nearest neighbor? So basically this k-nearest neighbor is a simple yet effective machine learning algorithm used for both classification and regression tasks. And it works by identifying the k closest data points or the neighbors to a given input and then using their labels or values to predict the output for that input. So imagine you have a map of the city with various neighborhoods. If you wanted to determine the type of neighborhood a new location falls into, whether residential, commercial or industrial, you could look at the k nearest locations on the map. And by examining this k closest locations, you can make an informed decision about the new location's neighborhood type. For example, if you set the k to 5 and the new location is a park, so you would look at the 5 closest locations to the park. If 4 of these locations are also park and the one other is a school, you would likely classify the new location as a park. And this simple decision making process is the essence of k nearest neighbor algorithm. So basically this k nearest algorithm is a non-parametric instance based algorithm, which means it does not require any explicit training. So instead it relies on stored data point or the instances to make prediction. And this choice of k is crucial and can have a significant impact on the algorithm's performance. So when the k is small, the algorithm is more likely to be influenced by local patterns, which can lead to more accurate predictions for similar input data. But when k is small, the algorithm may be sensitive to noise or outliers in the data. On the other hand, this large value of k, it can result in smoother decision boundary, making the algorithm less susceptible to noise but may miss the local pattern. So in practice, choosing an optimal value of k can be a challenge, and commonly used techniques include grid search or cross validation to find the value of k that yield the best performance. Basically, this KNN is powerful algorithm with several advantages. First is the simplicity, because it is straightforward and easy to implement algorithm. Then versatility, because it can be used for both classification and regression and can even be adapted to handle weighted distances. Then handling new data, that is, it can handle new data points effectively since it only requires the storage of training data without explicit model training. Then it can handle this non-linear relationship. So to summarize this, we can say this k nearest neighbor is a powerful and simple algorithm that works by examining the k closest data points to make prediction. And by understanding the impact of KN algorithm strengths, you can effectively leverage KNN for both classification and regression tasks. So to understand this better, let's understand KNN using a Python code. So in this code, first up, we will have a pip install scikit-learn. That is, this command will install the scikit-learn library, which is a popular machine learning library. Then in the next stages, these lines will import the necessary libraries like numpy, k-nearest neighbor, kernel density estimator, and the functions to generate sample data set. And then we will generate the classification data set. That is, this will generate a random classification data set with 1000 samples, 2 features, 2 informative features, 0 redundant features, and 3 classes. Then we will generate a regression data set with 1000 samples, 2 features, 2 informative features, and a continuous target. And then we will classify the sample data using KNN. And then we will create an instance of k nearest neighbor classifier with 7 as the value of k. That is the number of nearest neighbors to consider. And then we will train the KNN classifier on this generated classification data set. And finally, we will predict the class labels for the sample data sets. And finally, this accuracy term, it will calculate the accuracy score of the classification model by comparing the predicted class labels with the true class labels, and we will print this classification accuracy. Then comes the regression. So here we will create an instance of k nearest neighbor regressors with 7 as the value of k, and then we will train the KNN regressor on this generated regression data set, and then we will predict the values for the sample data set, and finally we will calculate the R squared score of this regression model by comparing the predicted values with the true values, and we will print the R squared score for the regression. So to summarize this, we can say that this code generates random data set for classification and regression task, trains the k nearest neighbor models on these dataset and evaluate the performance of these models using accuracy score for classification and R squared score for regression. Thank you.